Welcome to the course on nanotechnology. I'm Dr. Anita from Department of Physics. So we have been discussing about various nanomaterials, various semiconductor as well as metal nanoparticles or what we know as plasmonics, how they are embedded in nature, how people in the ancient days have used them for making wonderful creations. This type of nanomaterials can be made with varying morphology. For example, what you see in the screen are indium sulphide nanoparticles, which look like microflowers with spike-like features. These structures give rise to large number of applications, and not just these indium sulphide particles, many compound semiconductor particles whose size and shape varies from flowers, rods, wires, meshes, have multiple applications. They are used in sunscreens because of their ability to absorb ultraviolet rays which are harmful for the skin. The same nanoparticles can be used in making waterproof clothing, just like how a lotus leaf becomes hydrophobic. We can make super hydrophobic clothing out of these nanomaterials. These nanoparticles are also embedded into toothpaste, which helps in giving the white shine for the teeth. Similarly, there are lots of applications, like they are used in stain-resistant clothing, improving the strength of the tires, improving the performance of electronics, environmental remediation, etc. The nanomaterials have crept into almost every area of our life. I can choose one single nanomaterial, that is, I've chosen carbon nanotube, one single application, that is a car. The same carbon nanotube, by embedding it into various parts of the car, we have been able to improve the efficiency of the car. These carbon nanotubes, which are embedded into the windscreen, are able to provide a heating which helps in de-icing whenever there is a ice formation, or defogging is also possible because of the carbon nanotubes. Carbon nanotubes are extremely strong structures which, when embedded into the body of the car, are able to improve the strength, at the same time reducing the weight of the car's body. The carbon nanotubes are also embedded into the exhaust pipe of this car, and this helps in converting the carbon emissions into a better by reducing the carbon footprint or reducing the greenhouse gas emission. Carbon nanoparticles or metal nanoparticles, semiconductor nanoparticles, they are also having lots of application in biomedical industry. For example, nanobots have been designed which are able to do a targeted treatment. So these nanobots are attached with necessary sensors and also photothermal particles which are able to produce a specific amount of heating. They can sense the locations which are in your body which are either infected or having a cancerous nature or tumor formed. So these targeted locations are attacked by the nanobots, and when they are reaching the desired target area, they generate heat energy which can destroy the tumor or the infected region. So unlike the chemotherapy or antibiotic treatment where your whole body gets affected because you have to consume it or inject it into the bloodstream, this technology using nanobots does not affect the every organ of your body, but affects only the parts which are infected. The way we watch a movie or in a television changed largely by the advent of QLED television. QLED stands for the quantum dot television, where the color that you see from the television is more defined, precise and sharper, because we are going to use quantum dots whose color will now change depending on the backlit rays. So the number of quantum dots that the screen can have is also more, thus improving the resolution, also helping you in achieving a sharper image. So a smaller quantum dots will give you a blue color light, and a larger quantum dot will give you a red color emission. Since they are again light emitting, the color that you watch from the TV is more sharper, unlike the other LCD and LED TVs where the color is rather washed out. So all the display products, right, from television to your movie theaters and the display panels you see or the hoardings, the way we see structures changes and they can have a more realistic imaging. Nanocatalysts are also used for environmental remediation, for example, in water treatment. In India, one of the largest cause for pollutant is in the dye industry, right? From textile industry, leather industries, or any printing industry, the dye effluents are either left untreated or they are just released into lakes and rivers and made unusable for human consumption. So this is a very huge problem affecting aquatic life and also the cattle life. Because of this, government has declared that the dyeing unit has to shut down or they have to adapt any proper water treatment facilities. But most of the dyeing units and textile industries in India are small scale, which cannot afford such large scale water treatment plants, and hence they are shut down, putting the export industry at risk. So this is where nanotechnology comes into picture, where nanocatalysts are much effective, cheaper and non-toxic, and can be used for treating the dye effluents before they are released back into the rivers. So these treated waters, once after they complete the complete process of catalysis, the water is more pure and its toxicity is reduced. It also get disinfected, and the same water can be used for either releasing back into the waters or can be reused in the same industry. So incorporation of this nanotechnology has saved the shutting down of many small scale industry. Thank you.